Hi, my name is Kelly, and I'm going to walk you through the steps of getting the WRF and WPS code compiled on your system. I'll go through the steps one by one, starting with checking your system requirements, and then we'll move on to installing libraries, obtaining the source code, and then compiling the WRF and WPS, and then downloading static geographical data. Before trying to compile the code, it's important to make sure you have everything you need on your system. So we'll start with the hardware and software components that support WRF. If you are using any sort of 32 or 64-bit hardware system that includes a Unix-like operating system, that is perfect. Obviously, Linux machines include this, and Macs include a terminal utility that can be used as a command line interface. And if you are using a Windows machine, it is possible to use dual booting with the Windows and Linux operating systems built parallel to each other. And typically, any laptop, desktop, or small or large cluster will be suitable, depending on the size of your simulation. We put together this web page that is great for guiding users through the entire process, starting with system environment checks, installation of libraries, compatibility test, and then through the process of building the WRF and WPS executables, and even downloading necessary data and running the programs. The link for the page can be found here, and I'll walk you through some of the key information from this web page, but I would highly advise following it when you are actually ready to compile yourself, especially if you're running into compiling errors. Following this page word for word can increase your chance of a successful build. To build the WRF model, it's mandatory that you have a Fortran compiler, a C compiler, and CPP on your system. You can check whether you do by opening a terminal window and entering the commands which gfortran, which CPP, and which GCC. If you do have these installed, you'll be given a path for each command. Make sure your Fortran compiler is a newer version, at least version 4.6, which actually isn't that new anymore. But beginning with that version, it supports the Fortran 2003 standard, which is necessary for WRF. You can check the version by typing gcc-version in the command line, and it'll give you the version that you're using. If it is an older version, Fortran is a free compiler, so it won't cost you anything to upgrade it. You can then download quick tests that will check that your compilers are installed correctly and compatible with each other. You'll also need to make sure you have the C shell, Perl, and shell scripting languages available, as these are included in the WRF code. The WRF executables also have scripts as the top level for the user interface and makes use of these Unix commands. You likely already have these installed on your system, but if you don't, or if you are missing anything from the previous slide or get any failed test, you'll need to contact a systems administrator at your institution to get everything installed correctly. So assuming your environment is ready, you're ready to install the libraries needed to compile and run WRF and WPS. The only library that is mandatory for both WRF and WPS is NetCDF. You can use NetCDF versions 3 or 4, and it is not necessary to use the NetCDF4 capabilities, such as compression built with HDF5, to build or run WRF. But if you do need to use them, I recommend following this link for instructions on installing that correctly for the purpose of WRF. Most input data to the model will come in GRIB format. WPS can be built to use GRIB1 format without the need for any additional libraries. However, it's likely that you will need to use GRIB2 data files, and for that, you'll need to install 3 compression libraries, Jasper, PNG, and zlib, but they are usually very simple and quick to install. If you are planning on doing any parallel computing using multiple processors, you'll need an MPI library installed as well. In principle, any implementation of the MPI standard should work, but we have the most experience with MPitch, which is why we use that one as an example. Just to note, these libraries are not included in the WPS and WRF installation packages, so it is your responsibility to ensure they are installed separately. But the compilation website we've been discussing does include the library packages for downloading, along with compatibility tests and installation instructions. I also want to note that it is very important that all libraries are installed using the same compilers you will use to install WRF and WPS. Before installing the libraries, it's best to set several environment variables. These are all the ones that we recommend. You may not need them all, but you may need them, so it's easiest just to go ahead and set them. Obviously, this syntax is for C shell, so it will be slightly different if you're using a different shell like Bash. So this is an example of an installation for NetCDF. Assuming you have all the environment variables set from the previous slide, you'll start by unpackaging the NetCDF tar file. Then you'll go into that NetCDF directory. You first will configure, and we advise to use the following configuration settings depending on your needs. Disable DAP is set if you don't need to access remote servers for installation. Disable NetCDF4 is if you don't plan to use NetCDF4 capabilities like compression. And disabled shared disables compiling shared libraries, which can bog down compiling and make debugging difficult with complexities of shared libraries. After the configuration completes, you will enter make, and then once that completes, you will enter make install. If this is successful, NetCDF should now be installed, and you'll need to set your path to point to the NetCDF binaries, and also set the environment variable NetCDF to point to the place where NetCDF is installed. I won't go through the commands for each library installation, but they are all available from the compiling tutorial webpage. I would like to note, however, that the order of installation is important for some of the libraries. I would recommend installing NetCDF first, and when you're installing the GRIB2 compression libraries, libpng will depend on a successful zlib installation. Although you set some of these environment variables in your command line when building the libraries, I would also recommend setting these paths in your environment script, for example, your CSHRC file, so that they are automatically set each time you open a new terminal window. After you've installed the libraries, you want to make sure the libraries are compatible with your compilers. From the compiling webpage, you will find tests to ensure your Fortran, C, and NetCDF libraries are compatible. And if you installed MPI, you can test the compatibility of Fortran, C, NetCDF with MPI. To compile WRF and WPS, you'll need to first get the raw source code. And you can get that code from this link. If this is your first time obtaining the code, click New Users and then Register. You'll be sent an email, and once you confirm, you'll be able to log in to access the code. If you're a returning user, you can click on the Returning User link, where you'll be asked to enter your email, and it will allow you access to the information page. All of our code is available from GitHub, and there are two ways that you can get the code. If you are familiar with Git and Git commands, you can simply clone the code from GitHub. Otherwise, you can download the tar files you need and unpackage them on your system. To clone WRF from GitHub, you must have Git installed on your system, but it's very likely that you do. Most modern systems already include it. If not, and you are interested, talk to your systems administrator at your institution to get it installed. You'll type this command into the command line in a terminal window. The code will automatically download to your system and create a directory called WRF, which will hold all of the source code. And you're now ready to compile WRF. The first step is to configure the code. From the WRF directory in the command line, you'll type configure, or your system may require that you enter a / before configure. This will bring up a list of several options for available compilers and parallelism. I do want to note that the list may give options for compilers you don't have, so be sure to know what compilers are actually available to you. For each compiler, there's a serial option, which will only allow running with a single processor, an SMPAR or shared memory option for threading across multiple processors, a DMPAR or distributed memory option for use with multiple processors, and a DM plus SM, which is a combination of distributed memory and shared memory. Unless a single processor will suffice, we typically recommend the distributed memory option. We've done a lot of testing with this and have seen the most success with it. We don't really recommend using the DM plus SM option unless you're very familiar with it. So for this configure, we are going to choose option 34 for a distributed memory build with GNU. We enter 34 and then it will ask for our nesting options. We're just going to choose the standard nesting, which is option 1 or basic. After this, there will be a configure.wrf file in the wrf directory, and this contains all of the configuration information. When configuring, there are additional options you can choose for debugging and double precision. If you'd like to use any of these, just enter the commands instead of the standard /configure or configure that you're using. After that, you'll be given the same compiler and parallelism options as shown on the previous slide. Before compiling, I do want to point out that if you do have access to multiple processors, you can choose to compile the code with more than a single processor by setting J as is shown here. This particular command indicates we are requesting to use 2 compilers. And as a test, I chose different numbers of compilers to show how it can improve compiling time. This particular test was done with GNU or G4tran version 6.3.0, and we could see different behavior with different compilers, so keep that in mind, and possibly different versions of compilers. But here you can see using 2 processors instead of 1 decreases the time by nearly half. It cuts it down significantly again by adding 3 and then 4 processors. After that, the speed up becomes a little less significant, so it may not be necessary to use more than 4. Once you've configured, you'll compile the wrf code with the command /compile em underscore and then the test case name. If you're running a real data case, you will use em real. Otherwise, if you're planning to run an idealized test case, which you can get details for in the idealized presentation, you will choose one of these 3D, 2D, or 1D options for cases. When you issue the compile command, make sure to always request your standard input and errors to be sent to a log file by using the syntax > and then sending it to a log file, which this file can be named anything you want it to be. This can be very useful later on for troubleshooting if your compile is not successful. And just note that the compile will take several minutes, probably anywhere from 10 to 50 minutes, depending on what compiler you're using and how you're compiling it. So you may want to grab a cup of tea or something while you wait. If your compile is successful, you'll have a message at the end of your log file that says the executables were successfully built. If you compiled a real data case, you'll have 4 executables: the real and wrf.exe files, which initialize and run wrf, the indown program, which is a special type of one-way nesting you can use to run your domains separately, and tc.exe for tropical cyclone focusing. If you compiled an ideal case, you'll only have the ideal and wrf.exe files. All of these executables are built in the main directory and are linked to both the run directory and the test em case directories, and you can choose to run from either location. If your compile is not successful, there are a few things that you can do to troubleshoot. First, look in your compile log to search for errors. You'll want to make sure that you search for the word error with a capital E, and usually the first instance of that in the compile log is the one causing all the problems. When you know the problem, but you don't know how to fix it, I'd recommend going to the WRF Impasse A support forum. Check out the FAQ section there to see if your problem is mentioned, or try searching to see if you can find your problem with a resolution. If not, then post a new topic. Once you have a solution, make the corrections, and then you'll need to issue a clean -A to clean up the code, then reconfigure and recompile, and hopefully it will be successful the next time. So I mentioned the clean -A utility on the previous slide. This is just a script that is in your top level wrf directory that cleans up the code. If you are ever recompiling the code after editing the configuration or after making any modifications to the registry file, you'll need to issue a clean -A. If you are only modifying subroutines within the code, for example, in a physics routine, you do not have to clean the code or reconfigure. You will simply recompile the code and it will be much faster than a full compile. At some point before compiling, you'll want to consider your options for a compiler. This shows some very simple tests I ran to show the speed difference in a GNU or G4tran compiler and an Intel compiler. Obviously, there are other compilers that could be used, for example, PGI or AIX, but I just used these that were readily available to me. This compile timing test was with WRF version 4.0, and I chose the distributed memory and basic nesting options. I compiled with 4 processors, and then I did a timing test for running with the 2 compilers. The simulation used a very simple and small single domain with coarse resolution. I ran for 12 hours and used 8 processors to run. So first, it's important to note that GNU processors are free. So if you or your department don't have the funding to obtain an Intel license, you may have to go with GNU. As you can see, GNU has a strong advantage over Intel when it comes to compiling time. Intel took about 40 minutes longer to compile. However, Intel is faster with running. It may not seem like a dramatic difference between the two, but remember that this was only a 12-hour simulation. If you are running for several months or years, this would quickly become significant. The behavior could also vary depending on the version of the compiler, so you'll just need to make a decision based on your resources and needs. If you're planning to do code development, where you will need to modify code in small fragments at a time, which is recommended, you'll need to recompile the code often. Perhaps it makes more sense to use a GNU compiler for that purpose. However, if you plan to compile once and you're more interested in runtime and you have access, an Intel compiler would make more sense. So assuming WRF compiled correctly, you can move on to compile WPS. Just like with WRF, the first step is to configure. Again, you'll just type /configure. You'll once again be given a list of options, and you need to make sure you pick the same compiler you chose for WRF. I also want to point out that even if you compiled WRF with a parallel option, we typically recommend compiling WPS serially. The WPS programs run very fast, even for large domains. The only exception is if you are planning to use a domain with thousands by thousands of grid spaces, then you may need to compile with a parallel option. But even so, you still must always run the ungrid program serially. There is no option to run that with multiple processors. Once you configure, you'll get a configure.wps file. And then to compile, you'll just type /compile and send it to a log file. If it's successful, you'll have the 3 WPS executables linked from their corresponding source code directories. If you compile and you did not get the GeoGrid or MetGrid executables, it likely has something to do with your WRF compile or your NetCDF. Because WPS uses I/O libraries from WRF, it is important that WRF was successfully built before WPS. Make sure that your WPS compile is using the exact same compiler and version as you used for WRF, and the same thing goes for NetCDF. And also make sure that WRF is built where WPS expects to find it. It expects that the WRF directory is on the same level as the WPS directory and that it's called WRF, capital WRF. If that's not the case, you'll need to either modify the configure.wps file to point to the right location or change the name. Or if you're using version 4.0 or higher, you can simply use the environment variable WRF_dir to set the location and name. If your compile failed to build ungrib, it's likely due to the compression libraries. They either were not installed correctly or the path to them is not correct. In the configure.wps file, you'll see paths for compression libs and compression inc. Make sure these are pointing to the right location and that you are using the syntax that is shown here. Once everything is compiled, if you're running a real data case, you'll need to have the static geographic data to use when running the GeoGrid program. These are terrestrial data files such as land use and terrain. If you follow this link, it will take you to the WRF source code registration and download page. Scroll down a bit and you'll see a place to click to get to the static data. That will take you to a page with all the data files. You can download all the mandatory files in a single package file by clicking one of these options at the top. You'll notice we have a lowest resolution of each mandatory field package file, but this should only be used for code testing and educational teaching purposes. If you are doing any sort of real research or forecasting, you'll definitely want the highest resolution package. I do want to note that this is a very large file. When uncompressed, it's about 29 gigabytes. So if you have a shared space on a cluster, I'd recommend putting it somewhere where all the members of your group can access it so that each person doesn't have to download it and take up space in their personal directories. You can also download the files individually by clicking the link to each file. This can be useful if there are additional files you need that aren't included in the packaged file. Further down on that same page, there are a couple of other sections. There are some static data that are mandatory for using specific applications, and then some optional input data. So you can grab any of these if you need to. So that is all I have, and I hope this was helpful.